Okay, well, it is good to see y'all this afternoon, and we will get started with working on how to get some tips and tricks for math. My name is Carla Maynard. I'm with the Learning RX in Shreveport, Louisiana, and I am excited to have all of y'all join us today. The first thing I want to talk about is how can we work on some addition tricks? What are some ways that we can help our kids and students understand and do addition faster and without having to use their fingers? Because eventually they run out of fingers. So the first thing I want to show you is we've got a couple of things. We're going to go with some addition tricks right here. Let me share this with you. Okay, the first thing we want to do is we want to show our students that we have some dots, that I call them. And if you've ever been familiar with touch math, this is similar to touch math. I call them the dots, but we put dots on the numbers 1, 2, 3, and 4, just like that. And so that they realize where the dots are. There's one dot on the 1, 2 dots on the 2, 3 dots on the 3, and 4 dots on the 4. So then when they add a number to one of those numbers, you can start with the number like 7 plus 4, and then they just count up with the dots. Instead of using their fingers, they're actually going to use the dots. 7, 8, 9, 10, 11. So that would equal 11. 6 plus 1, 2, 3. Well, actually 6, 7, 8, 9. That would give you the answer for 9. So you can do that with any number that you're adding a 1, 2, 3, or 4 to. But when you get into the touch math and you use 5 and numbers above with touch math, they repeat some of where the dots are, and that tends to be a little confusing to some students. So I have some other tricks that we worked out without having to use the touch math when associated with the 5 or bigger. So when you get to the 5, there is we call it the high 5 trick. So you're adding a number to 5 that is higher than 5. So we're going to count up from the 5 to the 8, 5, 6, 7, 8. There's 3 of those things. So 3 numbers, 5, 6, 7, 8. So you have a 3 and you just put a 1 in front of that 3. That's all you have to do. So that would be 5 plus 8 equals 13. So then you have the 5 plus 7. You're adding a number to 5 that is higher than 5. You count up from the 5 to the 7, 5, 6, 7. There's 2. You put a 2, and then all you have to do is put the 1 in front of the 2, which makes it 12. So it also works with 5 plus 6. You just count up from 5 to 6. There's 1. You put a 1 in front of that 6, in front of that 1, and you get 11. So that's how we do the high 5 trick. So the double trick, that's when you have 2 numbers that are right next to each other in the number line, like 6 and 7 or 5 and 6. You can use the 5 plus 6 on the double trick or the 5 plus 6 on the high 5 trick. But the double trick is you double the small one and then you add 1. So 6 times 2 is 12, and you add 1 equals 13. This is also getting them into where they start to multiply. They can start to figure out what we're actually doing. When you say double, you're actually multiplying times 2. So, and very, very few, I don't know why this is, but very, very few students have I come across that don't already know their doubles. They can tell you what 3 plus 3 is, or 6 plus 6, or 8 plus 8, but they can't tell you what 8 plus 7 is, or 7 plus 8. So I always tell them, take the small one and double it. 6 times 2 equals 12, add 1 equals 13. Same thing with 5 plus 6. Double the small one. 5 times 2 plus 1 equals 11. 7 plus 8, double the small one. 7 times 2 equals 14, plus 1 equals 15. So that's the double trick. So then the last trick that I teach them, which is really one of the ones that is the most popular, that most people learn the fastest, is the trick with 9. So the trick with 9 is no matter what you're adding to 9, So what you're adding, no matter what you're adding to 9, you're going to take 1 away from that number, and you're going to put that 1 in front of whatever you get. So you're adding 9 plus 5, you're going to subtract 1 from 5 and get 4, and that 1 you subtracted, you put in front. So you get 14. 9 plus 7, you subtract 1 from the 7, and you get a 6. You put the 1 in front of the 6 and get 16. So no matter what you add to 9, you can subtract 1 from that number and put that 1 in front of your answer, and you get the answer of the total 9 plus whatever it is. So those are your addition tricks. Those are the fastest way. There's only one pair of numbers, and I actually didn't write it on this, but there's only one pair of numbers that doesn't have a trick. And so I tell my students, this is the one without a trick. 6 plus 8, if there is no trick for it, it doesn't have the dots, it doesn't work with a high 5, it doesn't work with a double trick because it's not right next to each other. So we just have to memorize that 6 plus 8 is 14. So I also have made sure that the students I work with do realize that when you have 2 even numbers, your answer is going to be even. When you have 2 odd numbers, your answer is going to be even. It's when you have the opposites, when you have an odd and an even, that your answer is going to be odd. Other than that, you always are going to have an even. It also, if we have time when we get to dealing with positive and negative numbers, that will also be a part of that as well. Wherever you have the same things that give you the same answer, or opposite things give you a different answer. Okay, and some of you may know what I'm talking about. But anyway, let's move on to some multiplication. The main thing about multiplication, subtraction is part of what we work with. Oh, well, actually, I went ahead and put subtraction here. Let's go ahead and do subtraction. So we use the same thing. There's going to be count up, count down, or the 10 pair trick. So count down, we're going to use the dots again. Use the same dots, 1, 2, 3, and 4. So whenever you're subtracting anything that's 1, 2, 3, or 4, you count down from where you're at. 7, 6, 5, 4. So your answer is 4. 8, 7, 6. So your answer is 6. So you count down based off of what your number is there, what number you have there. So if it's 1, 2, 3, or 4, that's how you get the answer. You count down. If you're subtracting 1, 2, 3, or 4, you count down. If you have a number that's higher than 4 that you're subtracting, you count up from where you are. So you start at the low one and count up. 5, 6, 7, 8, there's 3. So that's the answer. When it's a 7, 9 minus 7, you count up from 7 to 9, 7, 8, 9, and you get 2. So counting up is easier when you have the number, when you're subtracting something that's 5 or higher. Counting down is easier when you're subtracting something that is 1, 2, 3, or 4. So that's what I tell them whenever you're trying to subtract something that is within the same family. And when I say family, I'm talking about the 20s family or the 30s family or just the ones family. When you're dealing with the same family, you're going to count up or count down. Now, when you go to a different family, like when we want to say 14 minus 6 or 17 minus 9, you can use the 10 pair trick. One of the things that I focus on when I work with students is they absolutely, positively, without any doubt, need to know their 10 pairs. The 10 pairs are the numbers you add together to equal 10. You have 1 and 9, 2 and 8, 3 and 7, 4 and 6, 5 and 5. Always, 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 no matter what level your student is, they absolutely need to know what numbers add together to equal 10. Our number system is based on tens. In everything that we do in math, the patterns revolve around the tens. So if we can focus on the 10 pairs, then you'll be able to subtract a whole lot easier. Let me show you how this trick works. Okay, so we're going to talk about 13 minus 6. Okay, 13 minus 6. So what is your 10 pair with 6? It is 4. So you immediately take the 10 pair of what you're subtracting, add that to the ones digit in what you're subtracting it from. So your ones digit in 13 is 3. You add that to your 10 pair with 6, which is 4. 3 plus 4 equals 7. So that is your answer. So same thing with 9. 15 minus 9. What is your 10 pair with 9? It's 1. You add that to the ones digits. So you have 1 plus 5 equals 6. And that is your answer. Doesn't matter what you're subtracting, as long as it's something that's 5 or higher. Whenever you are subtracting it from something that's in the family next to it, like if you were to say 23 minus 8, you could take the 10 pair with 8 and add, which is 2, add that to your 3 and get 5. And then since your tens family, you need to go down one tens family, so your answer would be 15. That's the fastest way and the easiest way I've seen to have children understand. It's a little easier to do that with adding these tricks with adding and subtracting than just trying to count on your fingers. They get it. They get these a lot faster. Okay, are there any questions about those? Okay, all right, we're gonna move on to multiplying. Okay, so multiplication tricks. Okay, the trick with 5. All right, and I'll go over some other multiplication tricks that have used different numbers. Most every student knows the multiplication, how to double, multiplying times 2. Then we have some little rhymes and some little tricks that help them learn the multiplications that are not associated with these right here. Okay, so the trick with 5, it works with even numbers. This trick works only with even numbers, but you can do a little bit of a modification with some odd numbers. Whenever you use the trick with 5, what you want to do, whatever you multiply the 5 by, you take half of it. So you're starting to work on your actual fractions. You take half of it and put that as the tens digit, and then you put a 0, and that's your answer. It always is. Every time you multiply by 5, it's either going to end in a 5 or a 0. When you multiply 5 times an even number, it always ends in a 0. So the 5 times 8, take half of 8, it equals 4. So then you put the 0 after the 4. Same thing with 5 times 6, take half of 6, it equals 3, and put a 0 after it. What's even more cool, and my students really love this when they recognize this, this works even better, even for larger ones. I'm having somebody ask me if they can, if I can send them the link. Just a second. Let's see. There we go. Okay. All right. As far as the multiplication. Okay. As far as the multiplication, we want to use the trick with 5. We're going to do even with larger numbers, we can say it's 5 times 62. There we go. 5 times 62, you can take half of the 6, which is 3, take half of the 2, which is 1, put that there, and then add a 0, and you've just multiplied 5 times 62 completely in your head automatically. Same thing with things like 5 times 86. Half of 8 is 4. Half of 6 is 3. So you have 430. All you have to do is add a 0. It doesn't matter what number you are multiplying by, as long as you take half of it when you're multiplying by 5 and then add a 0. It's not as easy as when you multiply like 5 times 70, because half of 70 is 35, but not everybody, since 7 doesn't come evenly, you have to remember that it's 35. But 5 times 70 would be 350. Same thing, like if you were doing 5 times, if we wanted to do, can everybody hear me? Let me see if I can make this. There we go. Now I can see everybody. Okay. All right. If you wanted to multiply 5 times something like 74, you can take half of 70, which would be 35, half of 4, which would be 2. Hang on, let me write this over here. That's like 5 times 72, you could take half of 70, which is 35, and add that to half of 1, a half of 2, which is 1, and get 36, and then all you have to do is add a 0. So anytime you multiply times 5, you can take half of the number, if it's even, half of the number, and then add a 0. That's it. That's all you have to do. Okay. All right. So then that's when you multiply times 5. If you multiply times 5 on an odd number, there is a little bit of a trick to it. It still will work. The only difference is, let's say we want to take 5 times 7. What I tell my students is, what is the even number that is just less than what you're looking at? The 6. So take half of a 6, and instead of adding a 0 at the end, we're going to add a 5. So that's what, when you multiply by an odd number, when you multiply 5 by an odd number, you're going to end in a 5. When you multiply it by an even number, you're going to end in a 0. So that's the easiest trick that most of them remember the fastest. Just being able to know that you're multiplying anything times 5, and you can automatically come up with the answer, whether it's an even or an odd. And the even one is much easier. You just take half of it and add a 0. Okay. All right. Let's see. Okay. All right. Let's go with the trick with 6. Okay. When you're multiplying by 6, this is another one a lot of students have a lot of trouble with. The multiplying times 6. So what we're going to do is we're going to take half of the number you're multiplying by, like 6 times 8. Take half of the 8, and that's your tens digit. Then it ends in the digit that you say that you're multiplying by. So 6 times 8 is half of that is 4, and then it ends in the 8, 48. When you're multiplying 6 times 6, take half of the 6, that's your 3, that's your 30, that's your tens digit, and then it ends in a 6, 36. So anytime you multiply 6 times an even number, whatever you're multiplying it by, that is going to be what your actual answer ends with. So it also works with numbers that's higher than 6, 7, 8, 9, 10. You can multiply 6 times 72. It's going to end in a 2 because that's what the last number of what we're multiplying by is. So you're going to take the 2, it's going to end in the 2. You're going to take half of that 2, which is 1, and add it to what the 6 times 7 is. 6 times 7 is 42. 42 plus 1 is 43. And so your answer is 432. That can be a little complicated sometimes, but the more, if you do it and you practice it and you do it fast and you do it as much as possible, my brain now doesn't think of anything else other than how to do that trick when it's multiplying times 6. So again, here's another example. We're multiplying 6 times 68. It's going to end in an 8. You're going to take the half of the 8, which is 4, and add it to 6 times 6, which is 36. 36 plus 4 is 40. So your answer is 408. All you have to do is put what your answer is when you add those two, multiplying the 6 times the tens digit to half of the ones digit that you created, or that you just put there. Okay, so that's the trick with 6. This is multiplying tricks. You have a trick with, when you multiply, you have a trick with 5, trick with 6, and a trick with 9. There's two tricks with 9. I'm going to show you one with our hands. Some people don't always know this, but when I show them to you, they think it's crazy. I don't like to use my fingers that much, but this is what I do use. This is one trick I do show my kids how to use with their fingers, just to kind of help them. So when we're going to multiply 9 times, let's say 9 times 5, we're going to start with our pinky. 9 times 1, 2, 3, 4, 5. So there's 4 fingers on this side and 5 fingers on this side, 45. Let's multiply 9 times 7. 1, 2, 3, 4, 5, 6, 7. There is 60 fingers on 6 fingers on this side and 3 fingers on this side. 63. So whatever number you're multiplying the 9 by, you drop that finger, and what's left on the left and right of that is your answer. So if we multiply 9 times 4, 1, 2, 3, 4, we're dropping this finger. How many fingers are on this side? 36. That's your answer. So it works with every single number when you multiply 9 times any number between 1 and 10. And you carry your fingers with you wherever you go. It only works up to 9 or 10, but that's one trick that some students like to use. I don't necessarily like to use my fingers, but I have actually shown them that to show them and to prove to them. Let's look at this. Every single time we do this, we drop one finger. How many fingers are still up? There's always 9 fingers still up. So the 2 digits that are always created when you multiply times 9, the sum of the digits must equal 9. So with your trick with 9, the sum of the digits must equal 9. So when you multiply 9 times 4, just like when you added 9 plus 4, you take 1 away from the 4, that gives you a 3. That's what we did when we added. When we were adding, we took 1 away from what we were adding the 9 to. We're going to do the same thing when you multiply times 9. You take 1 away from what you're multiplying by. That now becomes your tens digit. No longer your ones digit, it's your tens digit. And then since the sum of the digits have to equal 9, what do you have to add to that number to get 9? So knowing your 9 pairs is also something that's very good. 10 pairs are absolutely a must. 9 pairs are also something I try to encourage our students to learn. So 9 times 4, you take 1 away from the 4, that becomes a 30. Then you subtract 3 from 9 to figure out what do you have to add to 9, add to 3 to get 9. You get a 6, so it's 36. Same thing with 9 times 8. Take 1 away from the 8, that becomes a 7. That's your new tens digit. And then you subtract the 9 from 7. Use your subtraction rules, count up. 7, 8, 9, you get a 2. So your answer is 72. So that's your trick with 9 when you're multiplying. You have to kind of review. I know some of y'all came in a few minutes late. Let me see if I can move this over. Oops, not on my mouse anymore. Okay. So we're going to come down here to the addition. This is the addition. We use touch math dots for 1, 2, 3, and 4. We have the high 5 trick, which means that you count up. Anytime you're adding a number to 5 that's higher than 5, you count up from the 5 to the 8, 5, 6, 7, 8. That becomes your ones digit, and you put a 1 in front of it. Double trick is when you add 2 numbers that are right next to each other on the number line. You double the small one and add 1. 6 plus 7, double the 6 times 2 and add 1, you get 13. Then when you have a trick with 9, anytime your trick with 9 is, you're going to subtract 1 from whatever you're adding the 9 to, and then put the number 1 in front of it. So 9 plus 5 is 14. 9 plus 7, subtract 1 from 7, you get 6. Put that 1 in front of it, you get 16. All right, and then the subtraction trick, you use the dots again on the 1, 2, 3, and 4. You count down when you're subtracting the numbers 1, 2, 3, or 4. 7 minus 3, 7, 6, 5, 4. When you're subtracting 8 minus 2, 8, 7, 6, you get the 6. So that's the easiest way to, when you're subtracting. When you're subtracting something that's higher than 4, you count up. You count up from 8, you count up from the 5 to the 8, 5, 6, 7, 8. There's 3 of them, so that means it's 3. When you are subtracting 7 from 9, you count up from 7 to 9, 7, 8, 9, it gives you 2. So you're counting, I don't like to count as much, but when you're counting, that is one of the easiest things to do. You don't have to use more than one hand, and you can usually keep up with it because you're not going to use anything other than 5s, bigger than 5s. The 10 pair trick when you're subtracting, Make sure you know your 10 pairs. Once you know your 10 pairs, then you can say 13 minus 6. You can use your 10 pair with 6, which is 4. Add that 4 to the ones digit you're subtracting from. So 3 plus 4 equals 7. Same thing with 15 minus 9, which your 10 pair with 9, it equals 1. Add that 1 to the ones digit. 1 plus 5 equals 6. And so that's how you get your subtraction. Okay, and we just went over all the multiplications. Okay, all the multiplication tricks. Now I'm going to teach you a few little things, a few little rhymes that don't go with any of our multiplication tricks. There's several little memory rhymes that I like to try to use. Let me do this. Okay, let's see. All right, so we're going to do, these are a few of the little memory things that I have worked out with some of my students. We're going to talk about 3 times 8. That's one that a lot of them have trouble remembering. So I tell them that there's not enough hours in the day. We would like to have at least 3 of our 12-hour clocks, but we don't. So we picture we only have 2 clocks. So we picture a clock in the top circle of the 8 and the top circle in the bottom circle of the 8. And so you know that 3 times 8 is only equal to 24. Not any higher. We don't have but 2 clocks. If we had 3, it would be higher, but we don't. So you have to get left with 24. Whenever we do 4 times 7, I tell them let's double the double. So what is the double of 7? The double of 7, hang on, let me put this over here. The 7 doubled is 14. So when you double the 1 and double the 4, you get 28. So and you can actually do that with any number you're multiplying times 4, but that's usually 4 times 7 is the one that they have the most problems with. So that's why I use that one. All right, so let's go back to this. That was the double the double. I'll put this right here. This is 2 clocks. This is double the double, which equals 28. And then we're going to do this is the pig in the shower. Okay, this is 4 times 8. Okay, now that 8 looks a lot like a pig. And so whenever a pig is being drugged to the shower, it doesn't really want to get clean. So he winds up squealing and pitching a fit and trying to keep himself from having to get drugged to the shower. And he starts hollering about the other pigs, and he says, he's dirty too. So that's why 4 times 8 equals 32. That is one that every one of my students remember the fastest. That pig in the shower. They can always think about that pig screaming, he's dirty too. 4 times 4. This is how old do you have to be to drive a 4x4? 4 times 4. You have to be at least 16 in order to drive a 4x4 truck. And I don't consider a 4x4 a four-wheeler. I consider it a truck. How old do you have to be to drive a 4x4 is 16. All right. And then when you multiply, 7 times 7, we have 2 soldiers. They're working and marching, and they are guarding Fort 9. So 7 times 7 equals 49. So you have to imagine that those 2 7s are 2 soldiers standing there with their gun ready to shoot, and they are guarding Fort 9. So that's what they're guarding. Fort 9. Okay. All right, and let's see, the 2 snowmen by the fire. This is another one that my students like to think. They think this one is funny. By the fire. This is 8 times 8. Again, the 8s can look like snowmen just as much as they can look like pigs, I guess. But when you have 2 of them, they're actually snowmen, and they're carrying the sticks. See where that star looks like a bunch of sticks? Or if you just have the multiplication sign, it's 2 sticks. And these aren't the smartest of snowmen, and so they are carrying these sticks, and they're marching to the fire. And as they're marching, they're saying, "These sticks are for the fire. These sticks are for the fire." So that's what they say. Sticks are for the fire. So it equals 64. Okay. We also have the 6 gave 7 the flu. Right there on the number line, they're right next to each other. 6 gave 7 the flu, and he slept from 4 to 2. So 6 gave 7 the flu, and he slept from 4 to 2. And if you've ever had the flu, you can probably attest that that's probably how long you slept as well. So that would be something that's that a lot of them will remember, especially if they've had the flu or know somebody that's had the flu. Okay, let me see. There we go. All right, and we've got one more of these, which is not really well, it's 2 of them, but there's not really a rhyme. It's just a little pattern that I've noticed. When you multiply 3 times 4, you get the answers that are 1, 2. So when you look at the answer 1, 2, 3, 4. So it's the 2 numbers just previous of the 3 and the 4. 3 times 4 equals 1, 2, 12. Same thing happens when you multiply 7 times 8. You get the 2 numbers that's previous. 56, 5, 6, 7, 8. So you can just tell them when you're multiplying 2 numbers, letter 3 and 4 and 7 and 8, you just get the numbers just previous of them, 5 and 6, 56, and 1 and 2. All right, so those are all the multiplication little rhymes and memory tricks to help the kids or help students know the best way to memorize. It gives them a little visual cue on what to do when they're trying to memorize some of their multiplication. So are there any questions before? Those are pretty much all the addition, subtraction, multiplication. Is there any questions associated with any of those? Okay. Is there anybody that has anything specific they wanted me to go over or wanted to talk about? Anything that they would like to have this? Is there a way that you can make this kind of thing easier? Okay. If not, we will go on to we'll do something related with fractions, because I know fractions is everybody's favorite friend. Okay, I'm going to show you a little trick that's related that I've used to help teach kids help teach students how to add fractions faster. So you can say like 3. This is not as easy to do, but we'll put a 5 here. And then I'll put a 4 and a 9. Okay. And so we're going to add 3/5 plus 4/9. Okay. 3/5 plus 4/9. Okay. So what I'm going to tell you to do is called the butterfly method. I don't know if anybody's heard of that. I've seen it on different places online, and it works. It's just, and it actually is making you find a common denominator, but it's easier for kids when they see it like a little butterfly. So let's make my little butterfly black. Okay. So I'm going to take and I'm going to multiply the 5 times the 4, and I'm going to get a 20 over here. And then I'm going to multiply the 3 times the 9, and I get a 27. And then I'm going to divide that by multiplying the 9 times the 5. And I'm going to get 45. So when I add those together, I get 47 divided by 45. That's my actual answer. Okay, now most of you, if y'all have any issues, if y'all look at that and recognize that's actually an improper fraction. Do you notice there's a butterfly? Improper fraction to a mixed number. Okay. All right. And whenever they do, whenever they do have questions with it, this is what I tell them. We're going to put the top number in the house. So we create a division problem. It looks like this. And we put the top number in the house. So you put the 47 in the house. Top number goes in the house. Okay. You can put the 45 out here. And then you're going to say 45 goes into 47 one time. 1 times 45 is 45. Subtract that. You get a 2. And that is now your remainder or your new numerator. So you take that remainder and it becomes your numerator over the 45. Your denominator doesn't change. Okay? So that's how you take an improper fraction or an improper fraction and change it into a mixed number. So let's do one that may be a little bit trickier. Let's do 18 that is over a 7. Okay, let's do 18 over 7. So the top number goes in the house. It's a phrase you need to remember. Top number goes in the house. Top number goes in the house. So we're going to put our little division problem here. We're going to put the top number in the house. And we're going to put the other number on the outside. So 7 into 18. 7 goes into 18 2 times. You multiply 7 2 times 7, you get 14. Subtract that 14. Get left with a 4. That 4 is now your remainder. Because 7 won't, there's nothing to drop down, and 7 won't go into 4 anyway. So that's your remainder. And so now you're left with 4 over 7. So that is what this changes to. It becomes 2 and 4 over 7. So that's the mixed number, 2 and 4 over 7. Okay, are there any questions about that? Okay, now some people have problems doing the opposite. They get a mixed number and they don't know how to change it into a improper fraction. So let's take a mixed number like 7 3/4, and we're going to take it and make it into a mixed number. I mean, not a mixed number. This is a mixed number. We're going to take it and make it into an improper fraction. So we're going to take, in that case, what I like to do, let me write it this way. Let me write it with this. We're going to take 7 3/4. Okay, what I like to do is I like to say we're going to loop it, loop-de-loop. Okay, we're going to multiply the 7 times the 4, which gives you 28. And then we're going to add your answer to 3. So 7 times 4 is 28. And then you're going to add the 3, which is 31, makes it 31. And you get equals 31, and then your 4 stays the same. So you get 31 over 4. So if you ever want to check, like when we made 18 sevenths and we changed it into 2 and 4 sevenths, we can loop it. That's what I tell my students. If you're not sure if you've got the right thing, then loop it. 2 and 4 sevenths. Let's loop it and see if we come back up with 18 sevenths. What's 7 times 2? 14. 14 plus 4 is 18. So you would turn out to have 18 divided by 7, or 18 over 7, which is equal to this. So 18 sevenths looped is, 2 and 4 sevenths looped does make it equal to 18 sevenths. So that's the easiest way to change improper fractions to mixed numbers, or mixed numbers to improper fractions. 2 phrases you need to remember. Top number goes in the house. That's when you change it from an improper fraction to a mixed number. Or when you have a mixed number and you need to change it to an improper fraction, you loop it. Those are your 2 phrases. Top number goes in the house and you loop it. That's if most people, they understand that, they remember that, they don't have any problems changing or dealing with fractions or mixed numbers or how they relate. Okay, any questions about that? Y'all are quiet today. Okay. All right, let's talk a little bit about percents. Okay, let me show you a few tricks related to percents. Okay, let's see. Let me pull my little sheet up here. Okay, the first thing I like to do is the 10% trick. All right, the 10% trick is related to anything that is a percent with a 0. And I use this all the time when I'm shopping because I like to be able to know how much. If it says it's 40% off, I want to know how much off it is. I don't want to have to get my calculator out and figure it out. So what I do is, let's say we have a dress that is normally $50 and it is 40% off. Okay. All right. So how much off is it? That's what we need to figure out. How much off is it? It is actually, so what we can do, you have to think about what is 10% of 50. Okay, 10% of any number is just move the decimal over 1 place. So the decimal for the 50 is right here. It's right there. So when you want to take 10% of it, you move it 1 place to the left, which gives you 5. So 10% of 50 is $5. So, and how many of those 10% do we need? How many 10% are in 40? 4. So we multiply that 5 times 4 and we get that it is $20 off. Okay. If we wanted to know how much we're going to actually have to pay for it, all we have to do is subtract 40 from 100. 140, if we know our 10 pairs, because 10 minus 4 or 10 plus what equals, 4 plus what equals 10, we know that we're going to have to pay 60% of the $50. We can do the same thing. We can take 10% of 50, which is 5, and multiply that times 6, because we have 6 of those 10%. And so we're going to actually have to pay $30. It's what we pay. Okay, so we're going to actually have to pay $30 for it. Now, the other way of figuring that out is if it's $20 off and it was costing $50, you can just subtract 20 from 50 and get 30. Whichever way is fastest for you, that's what you want to do. but we'll do another one just in case so you get it. We want to do, let's do 30%. Let's say we want to do, we have something that cost, let's do $80. It costs $80 and it's at 30% off this week. So we can take 10% of 80, which is 8, and multiply that times how many of those 10% do we need? 3. And we get that it's $24 off. Now see, it's not as easy to subtract 80 minus 24, so it may be easier to say we're going to pay 70% of $80. So therefore, we're going to take the $8 and multiply that times 7, and we get 7, 5, 6, 7, 8, 56. That we're actually going to have to pay $56. So that's the way, that's called my 10% trick. It relates to anything that has a 0%, like 70, 30, 20. That's the easiest way to figure out percents quickly. Just move the decimal over one time, especially if there's a 0, and then multiply that times however many 10% you need. Okay. All right. Let's go with, I just remembered something. Okay. So that's the 10% trick. Then we want to also be able to do the, when do you know what to do? Like if it says, when do you know to look for percent? The biggest rule that you need to know is, this is the biggest rule about percent. Percent equals the part over or divided by the whole. That is the biggest thing to have to remember. When you're looking at a word problem and it's asking you, it's wanting you to find how many students in total do you have. If you have 400 girls and that is 60% of the entire class or the entire school, how many in total do you have? That's when you use the of what trick. Okay. All right. Let me see, make sure I'm doing this. Okay. All right. So we're looking for percent of the whole, given percent of the whole. 10% trick. And then we're looking for the of what. So we're going to change the percent to a decimal and put part of the decimal over, put part of the part over the decimal. Okay. All right. So we're going to change it to like this. So let's say we have 400 girls in our school and they make up 40% of this school. How many students do we have in the school? Okay, so we're going to take that, and this is what I call the of what. So 400 is 40% of what? 400 is 40% of what? That's how you want, that's how you would restate this. 400 is 40% of what? Okay, so this is how you do an of what. You change the percent to a decimal. So you're going to take the percent and change it to a decimal. If you don't know how to do that, you just take it and move the decimal from right here and move it over twice and put the part over the decimal. So we're going to take this, now becomes, so 40%, 40% changes to 0.4, and then we're going to put that part, because this is the 400 is the part, and divide it by the percent or the decimal. So we're going to say 400 divided by 0.4. Okay, And so I'm going to tell you, if you don't realize that, the decimal in this case is 4/10. That is the place, that's the first number after the decimal is the 10th place. So when you're actually saying 400 divided by 0.4, you're saying 400 divided by 4/10. Okay. So what you can do is you can multiply. If you remember when you were dividing fractions, when you divide by a fraction, you flip the fraction over and then multiply it. So we're actually going to say that we're going to take 400 over 1, and we're going to flip the 4/10 over, and we're going to say times 10 over 4. Okay, so 400 divided by 4, because we can divide the 400 by the 4 first, and we can say this becomes 100. And this becomes 1 because it cancels out. 400 divided by 4, you cancel them out. 100 times 10 equals 1,000. So without touching a calculator, we were able to figure out that there's 1,000 students in the school. So that's the easiest way to do that. If you don't like having to flip those fractions over, that's fine. There's a lot of times I will say, when you're dividing, use the calculator. We all carry these calculators around with us everywhere we go now. So it's hard to say you're not always going to have a calculator, because you most likely will. As long as you're putting in the numbers correctly, that's fine. The thing about the thing about the of what kind that you need to remember is that the number, your answer, is always going to be bigger than what you started with. So 400 is 40% of what, so your answer should be bigger than 400. So 1,000 is bigger than 400. So that's usually typically the right answer on that. Okay. Now, what happens when you're looking for a percent? Let's say we have the basketball team won 15 out of their, let's say 45 games. Okay. What percent did they win? Okay, so now we're looking for a percent. We aren't looking for a part. We're not looking for a whole. We are given the part. The part was the 15. The whole is the 45. So what percent did they win? So what you have to do when you're looking for a percent, you put, remember our rule, the percent equals the part divided by the whole. So you put the part over the whole. So in this case, we're going to put the percent equals 15 divided by 45, which when you reduce that equals 1 divided by 3. So it actually equals, hang on, let me do this, equals 0.33. Now, that percent is in a decimal form in that case. So when you take that percent and you want to change it to a decimal, to a percent, you take the decimal, and this time, instead of moving it to the left, we move that decimal to the right, which would then move it to the right twice, which then that equals 33.3%. So what percent of the basketball games did they win? 33 1/3%. They probably need a little practice. So those are some tricks on how to deal with percents. You have the of what, and it's not really a trick. Those are just the 3 types of questions you'll be asked when you're talking about percents, and you need to be able to figure out which one they're asking you. Are they asking you, is this number is a certain percent of what? Are they asking you for the percent, Or are they asking you, what is the part that is this percent? So are they asking for which part of this equation, percent, part, or whole? That's how you're going to be able to know which kind to use. Percent, part, or whole. You use whichever one you need to relate to that particular equation. Okay, are there any questions about that? Are there any specific problems that somebody's come across that they haven't been able to figure out, or how to answer it? Okay. All right, let's move on to dealing with positive and negative numbers. Okay, here's the deal with positive and negative numbers. There's really only 3 rules that I teach that I work with students on how to do, which positive and negative numbers, and using and understanding percents and fractions are probably the foundation for what you need to be able to understand and use in algebra. So we're going to talk about adding positive and negative numbers. Okay, so here's the first rule. Adding positive and negative numbers. The first thing we're going to do is there is one option where the 2 numbers that you're adding have the same sign. 2 numbers have the same sign. Okay, that means they're either both positive or they're both negative. In that case, you just add the numbers together and put that sign. Okay, so if we were to say, what is 7 plus 15, or 7 plus 15, you've got 2 positive numbers. So you're adding the 7 plus the 15, you add the numbers together, and the sign is still positive. So 7 plus 15 would be 22. So now let's say the second rule. The second rule is the 2 numbers have different signs. Okay, so in this case, you subtract the numbers and keep the sign of the larger. Okay, so here's our 2 options. We're going to say 7 plus 15, that's going to equal 22. They're both positive. We're going to say negative 7 plus negative 15. So both numbers are negative. Whoops, I messed that up. Hang on. Plus negative 15. Both numbers are negative. Negative 7 plus negative 15. We're going to add the numbers together and get 22. But since both of them were negative, we keep our negative sign. So negative 7 plus negative 15 equals negative 22. All right, now that's rule number 1. I'll put that right here. This is rule 1. Okay, oops, 1. All right, now rule number 2 is the 2 numbers have different signs. So we're going to come over here and we'll put rule 2. Okay, so this time we're going to say 7 plus a negative 15. So we have a positive 7 and a negative 15. So the 2 signs are different. So we go to rule number 2. The 2 signs are different. So we subtract the 2 numbers. What is 15 minus 7? We can go back to our 10 pair trick. 15 minus 7, what is a 10 pair with 7? It's 3. 3, and add that to the 5, which makes that 8. So we know that 15 minus 7 is 8. So 2 numbers have different signs. You subtract the numbers, but you keep the sign of the larger. So which one is larger, 15 or 7? Well, the 15 is larger, so the actual answer is going to be negative 8. Okay, now what happens if the 7 were the negative 1? So we've got a negative 7 plus a positive 15. Okay, So when you have a -7 plus a +15, you again subtract the numbers, 7 minus 15, or 15 minus 7, and you get 8 again. But again, this time the 15 is still larger, but this time the larger one is positive. So your answer is a +8, okay? Those are the two rules with adding positive and negative numbers. Very important to know those and to remember those, because you will use those anytime you're adding or subtracting positive or negative numbers. Okay, now we're going to talk about subtracting negative numbers, because that is where a lot of people get confused. It actually has rules. It's just people don't know how to use it. Okay, so now we're going to subtract positive and negative numbers. Subtracting positive and negative numbers. Okay, rule number 1. Switch the problem to an addition problem by adding the opposite. Okay, that is a phrase I have seen my kids say over and over. They'll actually stop in the middle of trying to work some of these and say, add the opposite, add the opposite, add the opposite. If you remember this, you will not get this wrong. So we're going to switch the problem to an addition problem. Well, what's the addition rules? You already learned them. They're up here. So you're going to switch the problem from a subtraction problem to an addition problem by adding the opposite. Okay, so let's come with it. Let's see, we're going to say -7 minus 15. Okay, so we have a -7 and a +15, but we are subtracting them. So we're going to add the opposite. So we're going to switch it to -7. So we're going to add the opposite of +15 and say it's now a -15. -7 plus -15. All right, well, that looks a lot like this up here. -7 plus -15. So now we've just taken the subtraction problem and changed it to an addition problem by adding the opposite. Add the opposite of 15. So the adding the opposite of a +15 is adding a -15. So -7 plus a -15 equals -22. So that's what -7 minus 15 is. Okay. What happens if it is, we're going to say a +7 minus a +15. Okay. All right. So we're going to add the opposite. We're going to switch it to an addition problem by adding the opposite. 7 plus, and what is the opposite of +15? -15. Add the opposite. 7 plus -15, which now we have this right here, 7 plus -15, which equals -8. Okay, now what happens if we have a bunch of negatives? Okay, so let's change the same thing. Let's say, we're going to say -8 minus, hang on, I could keep all these in parentheses to make sure you understand where the negative goes. We'll stay with 7. -7 minus -15. Okay, so now we have everything's negative. -7 minus -15. How are we going to switch it to an addition problem? We're going to add the opposite. So we change it to -7 plus, what's the opposite of -15? A +15. So -7 plus 15. Whoop, looks a lot like this one right here. We subtract the 2 and put the sign of the larger, so that equals a +8. Okay, so -7 plus, that's -7 minus a -15 gives you a +8. Well, there's one other option where the 7 is positive and this, oops, oh no, 7 minus a negative 15. So again, we're subtracting a negative 15. So we're going to add 7 plus, and then we change the negative 15 to a positive 15. 7 plus 15 equals a positive 22. It looked like this one right here. So every single subtraction problem that you create, that you have, when you're adding or subtracting positive and negative integers, you can create into an addition problem. You don't have to get confused when you're subtracting a negative or positive. All you have to remember is this phrase right here: add the opposite. Add the opposite. Anytime you come across something where you're subtracting a number, you add the opposite. When you add the opposite, you'll always get the right answer. Okay. All right. Last thing on multiplying, we're going to multiply and divide positive and negative numbers. Okay. These are actually easier than subtracting and adding. There's only 2 rules with it at all. When you multiply positive and negative numbers, let me write this: multiply or divide positive and negative numbers. There's 2 rules. 1, signs are the same. The answer is positive. Rule number 2, signs are different. The answer is negative. Okay. All right. So it doesn't matter what the numbers are. It doesn't matter how big the numbers are. It doesn't matter how small the numbers are. It doesn't matter if the numbers are fractions or whole numbers or decimals or percents. If the signs are the same, the answer is positive. If the signs are different, the answer is negative. So let's do a few examples. When the signs are the same, we'll say, we'll do this, make one easier a little bit. We'll say positive 7 times positive 8. What is our answer? It is a positive 56. All right, we're going to say negative 7 times negative 8. The signs are the same. Your answer, believe it or not, is positive. So that rule never made sense to me, but it doesn't matter. I know it works. I know I'm getting the right answer every time I do it. But negative 7 times a negative 8 gives us a positive 56. Regardless of if they're both negatives, I'm still going to get a positive. 2 negatives equal a positive. 2 positives equal a positive. On the flip side, if I have negative 7 times positive 8, the 2 signs are different. It equals a negative 56. If I have a positive 7 times a negative 8, the 2 signs are different. So my answer is negative 56. Okay, it doesn't matter if the numbers you're multiplying by are percents, decimals, fractions, thousands, whole numbers, doesn't matter. If the 2 numbers are positive, the answer is a positive. If the 2 numbers are negative, if the 2 numbers are negative, the answer is positive. If the 2 signs are different, one's positive, one's negative, the answer is negative. Also, it works for the same way when you're dividing. So if we were to say, let's do 14 divided by 7, that's both of them are positive. 14 divided by 7 equals 2. If we were to say negative 14 divided by negative 7, the 2 numbers are negative, so my answer is positive 2. If we were to say negative 14 divided by positive 7, one's negative, one's positive, my answer is negative 2. If we were to say negative 14, or no, positive 14 divided by negative 7, One's positive, one's negative. The answer is -2. Okay, so those are very, very important rules to remember and to use as you're multiplying and dividing, adding and subtracting positive and negative numbers. Those integers, this is these things, especially with the adding and subtracting, are the things that most people do not get, do not understand when they start trying to do algebra. And it's absolutely becomes something that they cannot handle because they get confused with all of the, is it negative? Is it positive? Do I divide? Do I subtract? Follow those rules and you'll get it every single time. Okay. All right. Are there anything else that anybody, any other topic or any other interest that anybody has that you would like for me to go over? You can send me a message. I'll give y'all just a few seconds. In the meantime, I'm going to give you a list of books that Learning RX recommends. Let's see. Let's see. Okay. All right, I'm not seeing any messages. So let me give you a few list of books that might make math more fun for you to be able to use and with your students and with yourself. Let's see. Math, you can play combo. Multiplication and fraction. Math games for tough topics. Let's see, that actually goes with that one. Okay. All right. Let's see, 70 plus things to do with 100 chart. 70 plus things to do with a 100 chart. Let's play math. And pre-algebra and geometry, math games for middle school. Math games for middle school. All right. Are there any, these are some things, oh, and then, yeah, let's do that. Okay, and these are just some things that we've used. Some of these little tricks that I've showed you today are in some of these books. Some of them are not. I get asked a lot, how did you figure these out? How did you come up with these? Literally, math has been my favorite subject since I probably second or third grade. And I was always trying to recognize and look for the patterns in math. And I worked hard and did what I could to create, to not just create the patterns, but to recognize the patterns so that it would be easier for me to memorize them myself. And then also to be able to help my friends and classmates memorize whatever they were going on. So some of this I found from other people, but most of it I just kind of figured that out on my own. So any questions about anything? I know we still got a few minutes if anybody wants to have any questions, but that is pretty much all the math tips and tricks I know. Oh, wait, there's some chat. Okay. Oh, these books are by Denise Haskins. Let me write that down here. Let me see if I can. Okay. Okay, those are the author. And I appreciate y'all joining in with us, not on us, but joining in with us. And feel free to contact us. This whole meeting was recorded. So if you'd like to review it again, just let us know and we will send you a link to it. Alrighty, I appreciate everybody and I hope to hear from y'all soon. Thank you.